No power to lagi. One lecture चालू है.
ત્રીસ કે 878 કે ના 878 તો ના ભાવ આવ્યો ને ભાઈ આ તો દીકરી આવ્યો છે સાહેબ આ લ્યા મેં
પેલા ફરો તો ખરો.
આ તો દીકરી આવ્યો બોલ્યો મેસેજમાં કાલ આપતો બસ છે આમાં લખાઈ દો હા બસ છે પાછો 800 લીધા ગયા હે ને હા તો વસ્તુનો પાછો કઈ કરવાનું પાર્લર ના ના આમાં હવે સબસિડી બંધ થઈ ગઈ ને સબસિડી આવો તો બંધ
Okay, so last lecture we started the quantitative treatment of product distribution and reactor size. So ultimately, what we have to find out in this topic will be the what is the concentration of what is the concentration of desired product. For example, say we have a for example, A gives R and S. R is my desired product. So ultimate goal is what is the concentration of that what is the concentration of desired product. It means the ultimate goal is to find out the concentration of the desired product. That is the ultimate goal of this theory for the quantitative treatment of product distribution. How to find out the concentration of the desired product, and once I and which reactor I have to select so that I'm getting this highest concentration of the desired product. So what is the desired product and which reactor I have used so that I'm getting a maximum amount of the desired product concentration. For example, if I use mixed flow, then how much amount of desired product I am getting. If I use plug flow, then how much amount of desired product I am using. So reactor size and how to find out. For that this theory is saying. So there are two terms we discussed also in last class. There are two terms in quantitative treatment of product distribution. One term one is the psi. One first will be the instantaneous fraction yield. That we called as a psi. So what is the instantaneous fraction yield? For example, a reaction is start. After 2 minutes, if I want to find out what is the yield, so that to find out the at that point yield, that is we called as an instantaneous yield. We can define instantaneous yield by this way. Instantaneous yield psi is equal to moles of R formed per moles of A reacted. Moles of R formed divided by moles of A reactor. So it's ultimately the DCR, or I am saying also a CR, and divided by DCA. Then so this is the instantaneous yield. How can I find out the instantaneous yield? I have to draw a graph. So psi is a function of concentration. Psi is the function of concentration. We also calculate one example, and using that example you will correctly understand how to like how to calculate the instantaneous yield. Using instantaneous yield, how can we calculate the value of the concentration of the desired product? Psi is a instantaneous fraction yield is a function of concentration. So Ca changes in a reactor so psi is also changes. And now if I am using batch reactor, for batch reactor time changes concentration changes time changes concentration changes, it means psi changes. So for batch reactor with respect to time psi changes, it means at 1 minute instantaneous yield is different, at 2 minute instantaneous yield is different, at 3 minute instantaneous yield is different, 4 minute instantaneous yield is different. Okay, for plug flow reactor, length changes, it means the length of plug flow changes, concentration changes, it means the size changes. So ultimately in plug flow reactor, the length, according to length, instantaneous fraction yield is there. And for mixed flow reactor, only one concentration, so only one psi, it means only one instantaneous fraction. In mixed flow reactor, only one concentration. There is no change in concentration inside it, reactor and outside. So only one concentration, so only one instantaneous yield is there. So this is the information regarding the instantaneous yield. Once we calculate the example, at that time you can easily understand the value of the psi. And okay, now one raise hand, quantitative treatment એટલે that you understand, Asif. Now uh, uh, another one will be the another terms will be the overall fractional yield. Second one will be the overall fractional yield, which we called as a phi, which we called as a phi. Now we said that instantaneous yield is with respect to time for batch reactor, with length is respect to length for plug flow reactor, and we have only one side, so we don't worry about the mixed flow reactor. Now if I am saying that with respect to time phi is changing, but the what is the overall yield? Instantaneous yield is many instantaneous yield with respect to time. 1 minute different, 4 minute different, 3 minute different. Many instantaneous yield is there. But there is also one yield, that is the overall yield. In batch reactor, what is the overall yield? Which is contain integration of instantaneous yield, which is the integration of the instantaneous yield. Here plug flow reactor with 1.1 centimeter, 1 centimeter, 2 centimeter, 5 centimeter, 10 centimeter. There are different instantaneous yield, but the integration of the instantaneous yield will give me the overall fraction yield. So second one will be the what is the overall fraction yield? Overall fraction yield phi is equal to all R formed divided by all A reacted. All R formed multiplied by all A reacted. All R formed, it means CRF, final concentration of R divided by all of A reacted, we can define as a Ca0 minus CAF is equal to CRF divided by delta Ca. Now I am saying that mixed flow reactor only one concentration is there. So that one instantaneous yield is same as overall fraction yield for mixed flow reactor, because in mixed flow reactor no concentration changes, no instantaneous fractional yield changes. It means only one instantaneous yield, that is the final fractional yield. So here we can say it's a psi in MFR. Then it is the psi in MFR, or if I want to say fractional yield in terms of for other reactor, I am saying that psi is up related. It's a average of, or it's a all like what, like average velocity, average velocity. So it's like a phi dash or something in batch or plug flow reactor. Then, so if I want to find out the overall fractional yield for plug flow reactor, if I want to find out the overall fractional yield for plug flow reactor, so I can find out for plug flow reactor overall fractional yield for plug flow reactor. I can find out phi p is equal to 1 divided by minus 1 divided by Ca0 minus CAF is equal to integration Ca0 to CAF psi dCA, or we can also write down 1 divided by delta Ca Ca0 to CAF psi dCA. And we also draw a graph. Using graph we can find out the psi. And for plug flow reactor, sorry, for mixed flow reactor, and here batch reactor is also a same. Batch reactor is also a same, because plug flow reactor with respect to length phi changes, and for batch reactor, sorry, plug flow reactor with respect to length is changes, while for batch reactor it's with respect to time is changing, but overall both are remain same. So here for CSTR, phi m is equal to psi at any CAF. So only one CAF is there. So only whatever the psi is same as the phi of mixed flow reactor. So if I'm to find out the CRF, we don't worry about anything. Just we have to find out the CRF. We have to use only one reactor, only one, or we have to use this one. CRF is equal to overall fraction yield multiplied by CA0 minus CAF. That is the equation we have to use during the calculation of CRF. So I have to give the different name of the equation, and based on it, so this is the equation number 1. You have to remember this equation. Equation number 1. Equation number 2. Equation number 3. Equation number 4. Equation number 5. Now let's see how to calculate graphically. This is the using the equation. How can we calculate graphically? So for graphically, we have to draw a graph. How to draw a graph? So we have to draw a graph. We have to draw a graph. We have to draw a graph. Graph of phi versus CA. For example, I'm saying that I'm getting this type of graph. So here it's a CA0, and here it's a CAF. So what should I do? I'm getting two lines. I have to find out the area under the curve. And area under the curve, we have to find out CRF using two equation. Equation number 5 and equation number 3. Done. So ultimately we have to first draw a graph phi versus CA, and we'll calculate one example so you will clearly understand how to draw this graph. For example, this is for plug flow reactor. For example, if plug flow reactor we have to use, then how to calculate CRF? For example, if you want to calculate if I have a mixed flow reactor, then what we have to do? We have to draw a graph. For example, same type of curve will be there. Phi versus CA we have to graph. For example, this is the CAF, this is the CA0. So for example, CAF, here we have to draw a graph. Here we to go here. And this is the area under the curve for CRF from equation number 5 and equation number 4. Done? Okay. So this is the find out. Now I would like to calculate one example. Based on the example, let's see how to calculate the value of CRF, or how to calculate the value of the desired product concentration. So if you have a graph with you, then it's very good. If you don't have graph with you, then it's also okay. I will draw a graph in Excel. So let's calculate one example. Now we'll calculate the example and you will understand clearly the theory. Sir, phone maybe battery. So let me write down the example. Okay, the example are, using example we can understand clearly. Reactant A decompose as follow. A gives R, A gives S, and A gives T. R is equal to 1. This is given. RS is equal to 2C. RT is equal to CS square. These things are given. Now determine the N and here R is the desired product. Okay, first we write down, then we have said determine the maximum concentration. Determine the maximum concentration of desired product that is the R is the desired product. R is the desired product. In plug flow reactor, okay, and in mixed flow reactor. In plug flow reactor and in mixed flow reactor. Okay, R is my desired product. So what is the concentration of CR in plug flow reactor and in mixed flow reactor? Okay, so let's try to calculate this example. Solution. Okay, what is the psi? Psi is equal to dCr divided by dCA. Now you please concentrate on mobile in your screen. Psi is equal to dCr divided by dCA. Then and instead of dCA, can we write down this one? dCr is equal to dCr plus dCs plus dCt. It's okay. If instead of dCa, can I write down all these three one? Because dCa is having three. One is R, one is S, and one is T. So A is decreasing. So R, S, and T is increasing. So instead of dCa, we can write down dCr plus dCs plus dCt. Yes. So here it means ultimately the here, for example, it's a here dt will be there. Here dcr divided by dt, dcs divided by dt, dct divided by dt. So here dt will be common, here dt will be common, so it is a remove. Ultimately, okay, this one I'm writing down due to this reason. It's a rr divided by rr plus rs plus rt. So I can write down rr is equal to, what is the dcr value, rr value? Here 1, so I am writing down 1. So ultimately the psi is equal to 1. What is the rr? It's 1. What is the rs? It's ca. And what is the rt? It's sorry, it's 2ca, and rt is equal to ca square. Done. So psi is equal to, I can say, 1 divided by 1 plus 2ca plus ca square. So now I can write down this equation like this. 1 divided by 1 plus ca square, 1 divided by 1 plus ca square. I can write it down. What should I do? Now to calculate CRF, what I do to calculate CRF? CRF is equal to psi value R to A, because our ultimate goal is to calculate the R is a desired product. So psi R to A multiply by CA0 minus CAF or CA. So now we have to draw a graph between psi versus CA. So we put down the different value of CA, we get different value of psi. For examples, and here just one thing I forgot to mention here. We have to desired value of R whenever CA0 is equal to 2. That is the I forgot to mention here. CA0 is equal to 2. We have to put initial concentration is to 2. So what should I do? I have to put different value of CA. I have to put different value of CA. Once I put different value of CA, I am getting different value of psi. So we can put maximum CA0 is a 2. So and maximum CA0 2. So we start from 2 to 0. Now we have to decide how many things, how many duration we have to take. Let's take 0, 0.25, 0.5, 1, 1.5, and maximum CA02. So it's decreasing from 2 to 0. Now if we took CA is equal to 0, what is the value of pi? Can you write down in chat box? If CA is equal to 0, then what is the value of pi? If I put, okay, it's 1. Okay, so if CA is equal to 0, we have a instantaneous fraction is 1. If I put CA is equal to 0.25, then what is the phi value? 0.64. Okay, so at the can you finish this? Can you help me to finish this table? 0.5. Okay, 0.44. Very good. Some will start from here, some will start from here. Okay, very good, students. 0.44. So 1, 0.25, very good. So 1.5, 0.16. Okay, very good. And last value 2, 0.11. Okay, done. Very good, student. So now you see, whenever it's an initial concentration, at that time very less yield. Whenever the concentration is decreasing, yield is also increasing. Concentration decreases, yield increases. It means that once the reaction is there, my concentration decreases. In other words, my product is formation highest, and once the product formation highest, my yield is increases. So at Ca is equal to 0, I have a 1 instant yield. So now I have to draw a graph, phi versus Ca. So let me draw a graph in Excel. So just 1 minute, I open the Excel and would like to try to draw a graph. Just 1 minute, I open the Excel and then try to draw a graph. Okay, this is the Excel. Okay. Okay, Ca versus phi. Okay, Ca is equal to 0, 0.25, 0.5, it's 1, 1.5, 2. Okay. Phi value 1, 0.64, 0.44, 0.25, 0.16, 0.11. Okay, I have to draw a graph. So from this versus this. Okay, you see the graph. A very good graph is there. So here is a phi versus instant. This is like psi, huh? It's not phi. Psi versus. I do not add this psi in here, so I only write down psi Ca. I am writing down here psi. Let me take a very good okay. This one is good. Okay. So I take copy here and paste this here. Okay, I draw a graph 5 versus 6. Okay. Now, if first question, if I want to use the plug flow reactor, for example, PFR. If I want to use PFR, then how to calculate PFR? So first we have to calculate the area under the curve. So CA0 is a 2, CAF is equal to 0. So area under the curve. So we have to find out the number of boxes. So one box, two box, three box, four box. Here this one and this one, five box. Then this one and this one, six box. This one is nearly is there any mistake from my side? One minute, huh? 0, 1, 2. Okay, no, it's okay. So 0 to 2. So how many books? It's nearly, I'm saying that 1, let me again. Okay, 6.75. Okay, let's take 6.75 box. So if I take area under the curve, is equal to 6.75. What is the x-axis? 0.2. Here the 0.2 multiply by what is the, this one is 0.5. So final answer 6.75 multiply by 0.2 multiply by 0.5. 6.75 multiply by 0.2 multiply by 0.5. It's a 0.2 multiply by 0.5. 0.67. So CRF is equal to 0.67. Okay. Now, if I use the plug flow mixed flow reactor, then what should I do? I have to draw from here, and I have to go from here. So I have to, this one, the whole area under the curve I have to take. I have to take whole area under the curve. So can you tell me the how many boxes are there? So I'm removing these lines so it's easy for you. Approximate boxes, it's not exact answer I require. For MFR, area under the curve is equal to 0.5 multiplied by 0.2. Approximate 20 box. Well, we are saying it's a 20 box. Just 1 minute, Asif. So 20 multiplied by 0.5 multiplied by 0.2, it's a 2. And it means if I am using the MFR, then I'm getting the desired product concentration is 2. If I am using the PFR, then my desired concentration is 0.65, which is better to use. MFR is better to use for these conditions. For R, if my desired product is R, so use MFR is better, while use PFR is not better for me. Then, but if my desired reaction is, for example, if I here is not R, if my desired is not R, if my desired is S, then the different psi is there, different curve is there, and different type of desired product may be there. If my T is desired product, then the scenario something else. So according to the desired product and according to the rate equation, I can select the what is best for me for PFR or MFR for finding out the desired concentration. Okay. So now I'll ask Asif is raise your hand. So now Asif, you can unmute yourself and you can ask me a question. Yes, Asif, you can unmute yourself and you can ask me a question. You raise your hand. Or it's a by mistake. It's your mistake. Okay. Okay. So students, let me give you one thing. If S is my desired product, then which is better to use? So tomorrow, can you give me the answer? What is the better use reactor for PFR or MFR if S is my desired product where Ca0 is equal to 2? Where Ca0 is equal to 2, at that time, what will be the best reactor to use, MFR or PFR? Okay, so this is from my side. Now only one question, get question is remaining for the calculation of the parallel reaction for selectivity, yield and selectivity. So tomorrow we'll calculate one example. Using one example, we understand the concept of selectivity. You already studied selectivity means desired reaction divided by the desired rate of reaction divided by undesired rate of reaction. We'll use this one and get 2020 get example will calculate. So next lecture we have a last topic, that is the selectivity, and we understand the selectivity based on the GATE 2020 example. Now anything you from your side, you can write down in chat box. You can also unmute yourself and you can ask me a question. And for midsum 1, your syllabus is from the performance equation of batch reactor to do this one, instantaneous and fraction yield. Will not ask much question regarding the instantaneous and fraction yield. I not ask any question regarding it. Just I ask the questions up to the concentration is higher. Which conditions you have to use concentration is higher, up to that quantitative treatment, like parallel reaction first of it, up to it. This is not the IS. So this is your syllabus for the midterm 2, and the questions are MCQ. Now you can also ask me a question if anything you understand this concept, how to calculate the desired product concentration. My request is, if consider S is a desired product, and once S is desired product, what will be the CSF for PFR and for the MFR? Okay, you can unmute yourself, you can ask me a question, otherwise you can leave the meeting. હવે પાછો 11 ચાર લખે છે ને અઠવાડિયામાં અલગ અલગ હું જોવા કાલે પાછા પેજ લખે કાલે પેજ લખે ગુરુવારે શુક્રવાર પાછા 4 ઓલા દાવલા તો 20 લેક્ચર લેતા હોય ક્યાં પડે તો 20 છે તો અત્યારે કે ઓનલાઈન આમાં નવ નિર્માણ હતું 3 મહિના કોલેજ બંધ થઈ 4 મહિના કોઈ માસ્ટર કઈ ભણાયું કોઈ ન ભણાય હે કોઈ ન ભણાય. Yes, you can leave. If you don't have any question, then you can leave the class, because you have to join a next class. I also have a next class after 10 minutes.